kind of represents like a kind of a different breed of social neuroscientists coming up, who basically was really influenced by social psychology and social neuroscience, but also by computational methods like from Jim Haxby and other people that we have lots of integration in our department. And I think our work really reflects kind of the creative types of questions that can emerge from the pairing of these different things. And, welcome, Carolyn.
Thank you. Thank you so much for that very generous introduction, and thanks again to Luke and Matt and Jeremy for organizing mine and having me back this year. This is such an amazing workshop. It's always so stimulating and fun, and it's been so great to just get to know so many of you guys and to hear about your research and brainstorm ideas and all of that fun stuff. And the time has really flown by. I can't believe there's only one day left. And in case I run short on time at the end, I want to thank past and current members of my lab who've been involved in the work I'm going to tell you about today, especially Meng, who's here, and also Talia, my former mentor, who's probably like the toughest act to follow as a speaker, except maybe for Luke. I don't have any GIFs or GIFs in my talk, so just to kind of prepare you for a little bit of disappointment. But anyway, since this talk is all that kind of stands between you guys and eating lunch and finishing up your hackathon projects, I'm just going to jump right in. So this is sort of...
Adjust your mic real quick.
Hold that thought. Okay. Okay, so this is the outline for my talk. So I'm going to start by going over some work relating cognition as it unfolds within individual brains to sort of the networks of social relationships that we and, of course, our brains are all embedded in. And then I'm going to tell you a little bit about some new work testing if sort of the ways that we expect social networks to be structured shape our social interactions and how we learn and remember relationships between other people. And then finally, I'm going to discuss some work comparing how we mentally represent and navigate social relationship knowledge to how we mentally represent and navigate the physical space around ourselves. Okay, so first I'm going to go over some work combining, methods from psychology and neuroscience that focus on the individual with characterizations of where individuals sit in the real world social networks that they inhabit. And so some of this work is going to be really familiar to people at Dartmouth who were here last year and have heard about this, but I just want to kind of briefly go over some of that because it sort of sets the stage for what I'll talk about in the rest of the time that I have with you guys today. So these studies often start by taking everybody in some bounded community, so maybe a school or a dorm or a village of some sort, and just asking everybody who their friends are. Usually we use much more specific criteria than just saying who are your friends, but this kind of fits nicely on a slide. And then we can use this data to map out the social relationships between people in the community. And that's what you see here with the different colored circles, are different people, lines of friendships between them. And this kind of allows us to get a sort of rich set of information about these people without having to ask them very much, just who are your friends, and without really having to clue them in about what the rest of our studies might be about. So I'm just going to take a really brief moment and consider some of the aspects of social network position information that we can glean from this data that might be interesting for us to look at as social psychologists and neuroscientists, or maybe as anyone. So one thing you might care about that Talia alluded to is who occupies a really prestigious position in a social network, so who's really well-connected to well-connected others. So the big red circles here are sort of big fish in big ponds socially, people high in eigenvector centrality. You might also care about who tends to broker or bridge between different groups or otherwise disconnected people rather than being maybe isolated or embedded in like a densely interconnected group. And of course, there's a question of how far removed you are from anybody else in the network. So in its simplest form, geodesic distance, this is just playing the 6 degrees of separation game. And of course, there are many different ways of characterizing social network position. These are just a few of them that I'm going to focus on, and I'm happy to talk more about additional methods and measures later on offline or during the workshop later on today, anyone's interested. But basically we can take these people, characterize their social network, and then have some or all of them come into the lab to do behavioral or neuroimaging studies where we can ask questions about how we think about our social networks. So how much do we know about where other people sit in our social networks, and do our brains retrieve this knowledge when we encounter other people so that it can shape how we think and how we behave in a useful way, and also is how we kind of process the world around us related to the positions that we occupy in our social networks. So to begin to sort of answer this first category of questions, in one study a few years ago now, we mapped out the social network of a business school cohort using the approach that I just laid out, and had a subset come in for an fMRI study where we wanted to test how much people know about other people's position in the friendship network of the community, and if their brains sort of retrieve this knowledge spontaneously when they encounter each other. And so first, each subject saw a video like this of several of their classmates over and over while they're lying in the fMRI scanner. And the people who each participant saw were selected for them so that they'd vary in terms of distance from them in the network, how well connected they are to well-connected others, and the extent to which they broker a bridge between people. And then after scanning, we kind of quizzed people on their perceptions of this information. And so looking at the data from that post-scan quiz here, so the y-axes are perceptions, the x-axes are reality, each line is a participant. And as you can see, people are pretty accurate. Like, people seem to have a pretty good idea of these kinds of social network position characteristics for people in their real world communities. But is this knowledge retrieved when we encounter these people? So when a participant's just lying in the scanner and they see a video like this of someone who they know. So each point in the brain, as a few people have gone over now, so I'll just kind of be pretty brief in describing these methods, we can just extract the local neural response pattern to that person, everybody that the participant saw in the scanner, compare those patterns to each other to generate a neural similarity structure that gives us a sense of kind of what this brain area is coding, like what it's treating as the same, what it's treating as distinct, and by how much. And then we can also summarize each person's stimulus set in terms of those three aspects of social network position that I went over earlier. So for example, the purple similarity structure here captures how much the people in the stimulus set vary with respect to one another in terms of distance from the participant. And then this allows us to do things like, at any given point in the brain, see the extent to which each aspect of social network position might be encoded when you see someone who you know. So here, the colors represent what seem to be reliably encoded in a given brain area. And we see, for example, in orange, that who's really well connected to well-connected others is carried in brain regions that have been associated with, among other things, of course, mentalizing or making sense of others' mental states, which suggests the possibility that maybe how well connected someone is to well-connected others might have consequences for how much you attend to what they might be thinking. And so without getting into too much kind of like really wildly speculative reverse inference here, you can see that some of these results kind of automatically set up hypotheses that are testable about different kinds of processes that might be differentially triggered or influenced by different kinds of social network position information. And some of these are beginning to be borne out in some follow-up behavioral studies. So for example, we're seeing that people pay especially close attention to what really central people in their social network seem to be thinking about. And this kind of makes sense if you think about it, right? These people are really influential when it comes to things like spreading information, setting norms, shaping reputations. And people also care more about what happens to those who they believe are closer to them in social ties, even when they're strangers to them, even when their behavior is just going to be anonymous. So in these studies and some other studies, we're starting to see how this kind of information, once it's retrieved, shapes downstream processes and behavior. We're also beginning to see how our goals and our context shape what kind of social network position we encode about other people. So of course, different kinds of social information are going to be differentially relevant in different contexts. So maybe you're planning a wedding seating chart and you need to know where everybody sits in the social network. Maybe, so is this person like the groom's cousin or a bride's parent or something? Or you might want to spread information about something, and in that case, you might be more concerned with who'd be really effective at sort of seeding information and disseminating it. So the relevant information changes here based on what you're trying to accomplish, right? And so some ongoing work led by Miriam Weaverdick in the lab, we're testing how our brain sort of supports our ability to kind of effortlessly shift gears based on what kinds of social information is most relevant to our current context and our current goals. And one possibility is that this happens by sort of systematically warping neural representations to emphasize contextually relevant distinctions. So you can imagine that all these people are in a social network, and the size of the circle represents how many friends they have, and the more similar colors or people are more proximal in the social network to one another. And sometimes you might want to know who's popular, who's well connected. And in those cases, then your neural representations of these people might be organized by how many friends they have. So you might expect a representation that looks kind of like this, where the really well connected people like Jessica and Anthony are really close to each other and they're far away from the less popular people like David. On the other hand, you might be interested in other contexts in knowing who sits where in the network, and then your representations might look more like this, where you see the color kind of fade smoothly from yellow to red, and Jessica and Anthony are now much farther apart. And so right now we're testing how contextual relevance kind of shapes our neural representations of social knowledge, and this is still a work in progress, but what Miriam's finding so far is that many of the same regions that spontaneously encode social network position information when we encounter other people sort of accentuate distinctions based on what's relevant to your current context or goals. And so this is sort of consistent with the idea that the reason that we might encode social network position information at all when we encounter people is to sort of beneficially shape how we think and how we'll behave. So just kind of getting us geared up to act appropriately when we encounter other people by retrieving the right kind of information. Okay, so far we've seen how we can sort of integrate these levels of analysis to better understand how we think about our social networks. We can also ask if how we process the world around us is associated with the positions that we occupy in our social networks. So a lot of us have this sense that we're sort of friends with people who are like us, or, birds of a feather flock together, as the saying goes. And this tendency called homophily has been really widely documented by sociologists across a really wide range of contexts. But a lot of the research has been kind of focused in large part on pretty coarse variables. So things like demographics, for example. And this is despite the common perception that many of us have that our friends are people who we sort of click with, who kind of see the world in a similar way to how we ourselves do, and who kind of have similar perspective to our own. And so here we want to test this notion. And one window into how we respond to the world, so into things like our thoughts, our emotional responses, how we allocate our attention, and so on as these processes unfold over time, is provided by neural response time series to kind of dynamic, rich stimuli, as Luke very nicely set up, and Talia as well. So if you take a set of people, show them some engaging, time-varying stimulus like a movie, and look at corresponding brain regions as they watch a movie, their responses become sort of locked together in time. This is just a cartoonish depiction of this, obviously. and the similarity of their responses reflects similarity in things like their interpretations, what they remember later, how they interpret things, how they allocate their attention, depending where you're looking in the brain, of course. But if we are similar to our friends in these sorts of ways, then we'd expect our neural responses to sort of rich real-world stimuli to be really exceptionally similar to those of our friends. And so in this study, we again characterized the social network of a business school cohort, had them come in for an fMRI study where they just watched a set of videos, while we measured how activity across the brain rose and fell over time. So on top, you see data from 2 people, and on the bottom is that data summarized across space within that circled brain region in superior temporal cortex. Obviously, this brain data has been sped up a lot. We don't have that kind of temporal resolution, but it's just sort of give you an idea of what the data are like without having to linger too long on the slide. But you can see that these people look relatively in sync with one another. These 2 people also happen to be very good friends. And so here we want to see if these people, or rather if people in general who are friends or who are closer together in their social networks would have more similar neural responses, kind of rich real-world stimuli. And so here, warmer colors are going to mean more similar than average for a given brain region. Cooler colors are going to mean less similar than average for a given brain region. And so first, if we look at people 3 degrees away from one another in the social network, you see pretty cool colors. And then as we get closer in the social network, we see much warmer colors, suggesting that friends in particular were responding especially similarly to what they're seeing. And this is particularly pronounced in regions that determine things like how we allocate our attention, like superior parietal lobule, and regions that have been shown in other work, like in James Chen's work, to support sort of high-level representations of situations, like the angular gyrus. And so following that, in recent work with Meital Netta and Mengdu and Yu-Chen Li, a former student in the lab, we showed participants examples of situations that were sort of ambiguous and could be construed in multiple ways. So like this photo, some people might see this as like a positive situation. Maybe this person's anticipating a visit from family, like companies coming. Some people might have more negative construal, like maybe this person's worried about what's out there. And in 2 different samples, what we've been finding is that people who are closer together in their real-world social networks interpret these ambiguous images more similarly. And in some related work that I'll just super briefly touch on, we're finding similarities among friends when we aren't even showing them anything at all. So in some work that's been inspired by some of the work on functional connectome fingerprinting, that's shown that, individuating information about people and about their traits can be gleaned from sort of distributed patterns of functional connectivity. Here we're looking at the social network of an entire village on a remote island in South Korea, and we have resting state data on these people, and we find that we can predict how close together 2 people are in the village's network based on patterns of similarity in their functional connectome, even when we control for all the things you probably would want to control for, like demographics, personality, and so on. And so I'm not going to go into much detail here in the interest of time, and since this is kind of early work still. But hopefully this sort of, buffet of studies in the first part of my talk kind of gives you sort of a sense of how you can relate these sorts of levels of analysis. So individuals, how information processing takes place within them, within their brains, and then the broader social networks that those individuals inhabit. And so next, we wanted to test if kind of regularities in how our social networks tend to be organized might shape how we mentally represent social relationships between other people and how we interact with and perceive other people. So we've been examining this in a few different ways, and I'm just going to go over one particular study today, a project led by Meng, who's here at Mind, in collaboration with Miriam Weaverdick, another student in the lab, and also Luke here, and Yu-Chen Li, another former student. And so in this study, we're focusing on,
very different groups of people, so influence different clusters. So I wonder to what extent the significance of similarity in either friendship in the network we found was because it was a relatively homogeneous group where high heterosexuality and betweenness were correlated highly.
Oh, that's a good point. So I don't know the correlations between those measures in this sample offhand. Be interesting to look at. I will say that I guess, as I'm sure you're aware, like homophily has been demonstrating a broad range of samples, some more heterogeneous than others, but it will be really interesting to look at, especially now that we're not always using the same measure of interpersonal similarity, but looking at interpersonal similarity in different kinds of contexts is a really cool idea. Yeah, that's really cool. Yeah, thank you for bringing that up. Cool, so in this study that I'm gonna tell you about, basically we're interested in if homophily, so the tendency for people to be surrounded by others who are similar to themselves, might serve as kind of a social prior that sort of shapes how we expect other people to behave and how we expect other people to be connected to each other. And so if this is true, then we should expect, birds of a feather to flock together, as the saying goes. So, the similarity of people's behavior should exert some influence on beliefs about who's friends with whom. And the flip side would be that we should expect those who flock together to be of the same feather. So what we know about how others behave and the similarity of that should shape, or rather what we know about who's connected to one another should shape how we expect others to behave, and the similarity of that, especially when we don't have that much else to go on, like when we're interacting with strangers for the first time. And so to look at this, we had people come into the lab for a study where they thought we were interested in how various factors like, how much reward is at stake, for instance, shape enjoyment of games. And so we told them they're just going to be playing some games with different people online on a social gaming website that was being sort of developed and tested at a few different college campuses. So first we took their picture, made a little profile for them on this fictional website, and told them that the people they'd be playing with today are members of this website who log in and play games with each other for fun and to win prizes like money, as they would be doing today. And we also told them that members of this website get to rate one another now and then in terms of how much they like each other, how much they like playing with each other. And that these ratings help determine each player's top 3 friends that are shown with their profile on the website. So if you're old enough, or I guess if you're the right combination of old enough and young enough, you might remember MySpace, the top 8, or older days of Facebook where you could select the top friends that you want to choose to display on your profile. So this was meant to kind of be reminiscent of that. But we said that because of most users' privacy settings on the website, so the defaults, you wouldn't see this if you hadn't already interacted with somebody's friends before. So if someone hadn't met you before or played with you, you just see something like this. And luckily, participants believed this, and so this allowed us to manipulate their beliefs about friendship in this fictional community. And so this is the kind of thing that people saw when they were playing games with each other. And so first, it was time to sort of determine who's going to play what games. We told them there's like a rich tapestry of games that they could possibly assign to on the website. They all got assigned to play the very exciting investment game, which is just what we call the trust game. It's not that fun. And they're all assigned the role of player 1. And for anybody not familiar with trust games, I know there's a wide array of backgrounds in the audience here. I'll just really briefly go over what they looked like in this particular study. So you're the participant, you're given $5, and you can choose how much of that $5 to give to your partner, who in this case is Jin here. And any amount that you give him is going to get tripled and given to him, and he can choose how much to give back to you. So say you invest $3 in him, he'd get $9, and he can decide if he's trustworthy. He might choose to do something like give you $4.50 back, so it's sort of win-win. Obviously, it's not the only way to behave like in a socially affable way, but this is kind of a simple way. So he might give you $4.50, keep $4.50. It's good for him. He started with 0, he gets $4.50. It's good for you. You have a nice sort of return on your investment. If everybody's trustworthy, you might want to just invest as much as you can in them, right, to make the most money. But not everyone is trustworthy like Jen. So some people might be a little sketchier, like Eshin. So Eshin might take your $3 and he might give you nothing or very little back. And so here Eshin makes a very hefty profit, right? $9, started with nothing. You don't get any money back, sort of sucks, you're interacting with Eshin. But in this game, like in life, it's really important to figure out who you can trust, you can't, and then act accordingly. And so looking at how much people invest in their different partners in the game gives us a window into how much they trust each one of them, how trustworthy they think they are. And so in block 1, after participants had joined the community, they played a bunch of trust games with a few different partners. Some of whom were trustworthy, so their return rates were drawn from a distribution centered around 50%. Others were untrustworthy, so their return rates were centered or taken from a distribution centered around 5%. And they really easily learned over time who was trustworthy, who wasn't. As you can see in this graph here, where people are just investing more in trustworthy people over time, investing less in untrustworthy people over time. But it was the next part of the study that we were more interested in. So now that our participants have joined this fictional community, they've gotten acquainted with some of its members, so they have a sense of how some of these people tend to behave. What happens when they meet these people's friends? So what happens when they're paired with new people and are shown some friendship information? So in block 2, participants were again assigned the investment game. And they played with new partners, and for some of them, they could see some friendship information about them. So it's just an overview of the different partners they might play with. So some people were trustworthy, some people weren't. Some had trustworthy friends, some had untrustworthy friends, some had no known friends. And they also varied in terms of the consistency of their offers. So some had offers or return rates drawn from a wider distribution. Some had return rates drawn from a narrower distribution, so they're more predictable. In the interest of time in this talk, I'm really just going to focus on the predictable partners, but I'm happy to chat more about sort of the full picture of the results with anyone interested in. I just want to make sure to get through sort of a few different things today. So in this study, in this part of the study, you might meet a new person like Mark. You don't know anything about Mark yet, but you see that Mark is friends with Eshin. And so first we want to see how this knowledge of relationships between third parties, so this knowledge that there's some friendship between Mark and Eshin, might shape your expectations about how Mark's going to behave. So this is true when you first meet Mark, you might expect him to be untrustworthy since he's friends with Eshin, or if he's friends with Jin, who you'd previously learned was trustworthy, you might expect him to behave trustworthy as well, or you might also expect someone to be relatively trustworthy, perhaps if you don't know anything about them yet. So you don't know anything about who their friends are. And so basically what we find is that people initially trust others less if they have untrustworthy friends. So here the y-axis is how much people invested on their first trial with the new partner. The x-axis is what people know about who they're friends with. And you can see that people are investing less on the really first trial in people who are shown to have untrustworthy friends. And this persists, albeit to much subtler extent, when participants have had the chance to learn what these people are like through direct interactions, but only really for players who are trustworthy themselves. So when someone's untrustworthy and you learn that, it doesn't matter what you know about their friends. You're just not going to trust them. But for trustworthy partners throughout the study, people are investing more in those who had trustworthy friends. And we also wanted to see if these effects would extend beyond the context of the game. So next we had participants rate their partners according to how much they want to play them again in a new cooperative puzzle-solving game they might get assigned to later in the future, or have the chance to complete in the future, rather. And so we wanted to see if these ratings would also be shaped by knowledge of their partner's friends, even though they're making decisions about interacting with people in a new context, and even though participants have had a fair chance to learn directly from interacting with these people what they're actually like. And so here, preference ratings are on the y-axis, orange bars are trustworthy partners, yellow is untrustworthy, and the x-axis corresponds to if the partner had a trustworthy friend, an untrustworthy friend, or no known friends. And you can see that for trustworthy partners, even though these people are all behaving identically themselves, participants prefer them less as future partners if they have untrustworthy friends, even in the presence of sort of countervailing evidence from their own behavior. So even though these people are all consistently showing you that they're trustworthy, you're going to want to play with them less in the future if you know that their friends are untrustworthy. And so this is all sort of consistent with the idea that people assume that those who flock together will be of the same feather. I guess a sort of twist around that phrase, right? That people who are friends with one another are going to behave similarly to one another. But you might wonder, well, what about the other side of the coin, right? The more common version of that phrase is birds of a feather flock together. So do people assume that those who are similar to one another are more likely to be friends? So we also gave people just this incidental memory test at the end of the study, where they just see a series of matrices of all the possible pairs of people in the study, and they just go through each cell of each matrix and indicate by clicking on an option if they think these people were displayed as friends with one another or not in their interactions with them during the study. And what we're really interested in when looking at this data is the patterns of errors people will make. So specifically, would people be more likely to think that there are friendships erroneously between people if they behaved similarly? And so here on the y-axis is the false positive rates for friendships. So basically, how often people indicated friendships that didn't exist between pairs of partners. And the x-axis and color of the bars correspond to whether the relationship in question is between two individuals who had similar behavioral tendencies, so two trustworthy people or two untrustworthy people. That'd be in light purple. Or if the relationship in question is between pairs of people who had differing behavioral tendencies, so one trustworthy person, one untrustworthy person, shown in dark purple. And the different panels here correspond to if both partners had really consistent, predictable patterns of behavior, if one of them or if both of them were more variable. And we see in general that people are much more likely to mistakenly remember two people as friends if they had behaved similarly. And this effect is really driven by cases when these people were behaving really consistently themselves. And so these results sort of support this idea that we assume that people are going to be surrounded by similar others. And this leads our beliefs about how others behave to color our beliefs about who's connected to whom in social ties, sort of vice versa as well. And so in the last part of my talk, how am I doing on time? Okay, in the last part of my talk, I'm going to shift gears a little bit and just quickly go over a little bit of research testing if sort of shared neural mechanisms support our ability to sort of encode and navigate knowledge of social relations and the physical space around ourselves. I'm going to skip over the study on social, physical, and temporal egocentric distance since Talia went over it like 90 minutes ago, and just kind of briefly tell you about some newer study, some newer work led by Meng here, where we're testing if there might be other sort of interesting parsimonies in how our brains encode and operate on knowledge of social relations and the physical space around ourselves. In this study, so here is an overview of what participants did in the study that I'll very quickly tell you about. So on day one, they come in and they have to learn about the social hierarchy of an organization. I won't go into detail about the paradigm. I'll just point you to two studies by Kumaran and colleagues, a couple of neuron papers where they developed this nice paradigm for learning about social hierarchies. And the important thing here is just that people learned about relative status between others, and also that in our adaptation of this paradigm, they never see any spatial configurations between other people. And then we had people practice a task that they were going to do in the scanner where they had to mentally navigate the social hierarchy. So this is what people do in the scanner as an example of a trial. So first, they're going to see a face from the social hierarchy they've learned. So we'll call that the reference face. And then they're going to get an instruction that tells them how many steps they need to travel in the social hierarchy, and also the color of the number tells them what direction sort of they need to go. And so here, yellow means up for this participant. And so this means that the participant has to figure out who's 2 sort of steps above the reference face in the social hierarchy. So this time period where people are mentally navigating the social hierarchy is what we're really interested in. So they're not seeing the people, but they're trying to reason about relationships between them. And basically, what we hope is happening in this time period is that people are mentally traversing from the reference face, shown on the right here, to another point in the social hierarchy to sort of arrive at the right answer in their mental representation of these social relations. And then they select their response and get some feedback. And so this is an example of what a trial might look like for downward navigation in the hierarchy. You get the idea, it's just the other direction. And so first we want to see or look at what brain areas might encode the direction of shifts of attention in knowledge of social relations. And so we first wanted to look at the superior parietal lobule, given some previous work implicating this region in encoding the direction of attentional shifts. And so first we looked at how similar response patterns were across runs when people are navigating in the same direction, the social hierarchy. So the similarity of 2 up patterns or 2 down patterns across runs, signified by these dark green squares here, compared to when people are navigating in diverging directions in their knowledge of the social hierarchy. So up versus down patterns, signified by the lighter green squares here. And what we find briefly is that bilaterally, the SPL, which we know has a long-standing role in encoding shifts of attention in external space, also encodes shifts of attention in kind of knowledge of social relations that are, I guess, internally represented. So you can see the patterns are more similar for shifts of attention in the same direction than in different directions. And then we also had a task at the end of the scanning session to measure patterns corresponding to the directions of overt shifts of visual attention in external space, so basically eye movements. So people just followed a fixation across the round screen, went up, down, left, or right. And basically, we found that the same brain region, as you might expect, was encoding the direction of shifts of attention in external space and in internal representations of the social relationship knowledge. And so lastly, we wanted to see how these different functions might relate to one another. So after participants got out of the scanner, they did this open-ended task where they just drag and drop the faces from the hierarchy into whatever configuration they felt best matched their relative status in the organization they'd learned about. And then we use these sort of mappings given to us from each participant to inform how we're going to compare neural patterns going across domains. So most people arrange the faces vertically or in some kind of vertical-ish orientation. Some people do something a little bit different, as you can see here. But in the next analysis of the fMRI data, we wanted to see if shifts of attention in the same direction in space and in knowledge of social relations would look more similar than shifts of attention in diverging directions across domains. So if people arrange the faces top to bottom here, then we would consider shifts of attention literally upward in space and upward in the social hierarchy as matched. But if they arrange them left to right here, we consider shifts of attention upward in the social hierarchy to shifts of attention leftward in space and so on. And basically what we found when we did these sorts of analyses going across tasks, we didn't really see systematically more similar neural responses for matched directional shifts across domains in the IPL, as you can see here. And so what this suggests is that this region might contain kind of overlapping but distinct codes for shifting your attention in external space and in internal representations of social knowledge. And so I'll just super briefly go over, I guess, we also just did some exploratory analyses looking beyond the SPL, both looking at anatomical ROIs, iteratively just using free surface parcellations and using a whole brain searchlight approach. And we basically see that there's a lot of overlap, particularly in posterior parietal cortex and some regions of occipital cortex, in the brain regions that encode the direction of shifts of attention in space and social knowledge. But when we compare the distributed response patterns across domains, we see that these sort of spatially coincident results seem to be reflecting like overlapping but distinct codes for these two kinds of mental operations. So just to sum up, since I think it's lunchtime, hopefully what I've shown you today is that there's some interesting relationships, right, between how people process the world around them and where they sit in their real-world social networks, and our expectations about how these social networks will be structured color our perceptions of other people, both what they're like and how they're going to be tied to one another. And there seems to be some interesting overlap in the neural mechanisms that support our ability to encode and navigate space and social relations that surround us. And so I think just, by combining approaches, I guess, for studying individual cognition and sort of the patterns of social relationships that surround each one of us, we can open up a lot of exciting and fun questions, because as Talia alluded to in her talk, we really just don't want to treat people as isolated units or even just as dyads. We're just looking at how one person is responding to or perceiving one other person in isolation, because we're really not going to be able to tell the whole story about social thought and behavior if we limit ourselves in this way. Because oftentimes what's really going on sort of under the hood takes into account these webs of social relationships that surround us. And obviously this is still a pretty young field, so there's still a lot of kind of, I think, interesting and fun questions to ask, and sort of a fun kind of scientific sandbox to play in, I guess. And so with that, I guess, thank you for your time and attention, and I'm happy to chat more either now or at lunch or throughout the workshop.